Welcome back. We are about to start Chapter 11. This is Unit 7 in Math with Business Applications. I am Amy Fuchsteiner, your instructor for this course, and we're about to learn about compounded interest. So we're going to be looking at Chapter 11 from your textbook. Compound interest, we're going to be doing future value and present value. Today, we're going to start with Section 1, which is the time value of money. Our goals for this afternoon are as follows. We're going to work through a manual calculation of compounded interest in order to help you understand the difference between the simple interest that we have been doing and the compounded interest that we're going to be doing. We're going to use what's known as the future value table. You will find a copy of this future value table on Blackboard in this week's assignments. If you don't find one, reach out to me and we'll make sure to get you a copy. We're going to have to calculate the interest rate per period as well as the total number of compounding periods, and then we'll use a table factor in order to calculate our compounded amount. From there, I'm going to ask you to separate the interest from the principal. Can you tell which is the interest and which is the principal? We're going to learn how to calculate a table factor beyond the table that you have for usage. We're also going to talk about the annual percentage yield. We're going to be able to calculate it, and we want you to be able to understand what it is and who uses it. Lastly, we're going to use the compound interest formula, which is available to you at all times, even when the tables are not. We're going to go over the different parts of the formula. We want you to be able to identify those, and we're going to be using a calculator with power keys in order to determine the compounded amount. And of course, we'll want you to be able to separate interest from the principal when using the compounded formula as well. So to begin with, the time value of money is a phrase that refers to the idea that money collected today in the present has the potential to be so much more in the future. So money has a value that's dependent upon allowing it time. Putting this a slightly different way, if I have the option of giving you $10,000 today or $10,000 in, say, 5 years, which one would you take today? It's the same amount of money. I'll just give you $10,000 today, $10,000 now, or I'll ask you to wait 5 years and you'll get the same amount of $10,000. Most of the time, we will take the money today because money that we are able to invest today will be worth more money in the future. This is known as the time value of money. So the time value of money is based upon compounded interest. We have 4 ideas here. If you look at somebody who's in retirement or a simple savings account, perhaps they're paying off a mortgage or a credit card. All of these things have in common that they are calculated using compounded interest. This is, we're adding interest onto an account at regular intervals, which we call periods. And we have the opportunity to earn interest on that interest. And if we've borrowed money, then we get the opportunity to pay interest on interest. That's why it's compounded. It just gets more and more complicated as things go on. So there are some terms that we need you to be aware of as we do compounded interest. The first is the idea of present value. This is the money we have now. In the here and now, the money is worth what we say it is worth. $10,000 is worth $10,000. That is its present value. The future value is the money that we will have once the compounded interest is included. So the future value of the money depends upon how we're able to invest it, for how long, at what rate, and how often it is compounded. The time value of money we just talked about. That is that all money and assets can be considered to have both a present value, which is face, and a future value. The opportunity cost is another phrase that you will hear get sort of bandied about a bit, tossed around. This is the idea that there is a change in the future value of money depending upon the decision you make. That means if I decide to put it in a CD versus a savings account versus the stock market, there is an opportunity with each one of those and an opportunity cost. And that sometimes even the decision to do nothing could cost me money or could gain me money. This is known as the opportunity cost. As we calculate some of these ideas, as we calculate some of these values, there we go, we need to have some information. So let's be clear. The principal is the same as it was before. It is the amount of money that is borrowed or invested. The interest rate, same as before. It is going to be listed yearly. In other words, we'll know it's 8% interest for the course of the year or 3% interest for the course of the year. This is known as the nominal or yearly interest rate. However, because we're compounding, that means that at regular intervals called periods, we will need to know what that interest rate is broken down into those periods. We're going to look at the compounded periods, which, as we said, are stated over the course of a year, but we're going to calculate them over the time of the loan. So we'll need to know both things. How many periods are there in a year, and then how many times over the course of the loan? The time in this case, as it was with simple interest, will be given to us in years. Now, I have a graphic on this page that goes over the different compounding periods. So the different compounding periods that we're going to look at are first annually or yearly. This one makes the most sense. It means that there is one compounding period for each year that you have the loan. The second compounding period is known as semi-annually. There we go. Here it comes. Semi-annually means we're compounding twice in a year, every 6 months. Those are our regular intervals. So there are 2 compounding periods in a year. Quarterly is what it sounds like. Quarters are 4, so there are 4 compounding periods in the year. Monthly, there are 12. Daily, we say 365. There is no ordinary interest when we're dealing with compound. It is always exactly 365 days. There is also something known as continuous compounding. Now, continuous compounding requires a depth of mathematics that is not needed for this course. We need logarithms and exponentials for continuously compounding interest. So if you've had, say, a pre-calc course, you've probably dealt with some of this. We're not going to be dealing with it in this class. So let's try one problem that we're going to do manually. So Charlie places $1,500 in an account that earns 4% interest. We're going to compound it semi-annually. That's 2 times a year. We want to manually calculate the compounded interest over 2 years. So what happens is every 6 months, because it's twice a year, so 2 times a year at regular intervals, every 6 months, we're going to calculate what the interest is, and we're going to put it into the account and add it to the principal. So in the first 6 months, we're going to look at just interest as principal times rate times time. Our principal is the $1,500, our rate is 4%, and our time is the first 6 out of 12 months. This is $30. So those $30 are then going to be dumped into the account or placed into the account. So our new value or maturity value of the account is the $1,500 plus 30, or $1,530. Now, that means when the second 6 months starts, we're actually going to be calculating interest on the new principal of $1,530. That's 4% for the next 6 months. That gives us interest of $30.60. Notice the interest increased just ever so slightly, right? So now we're going to take that interest and we're going to add it to the $15.30 that was already in the principal. That gives us $15.60.60. That becomes our new principal for the next 6 months. So when we calculate interest on this one, we're going to be using the $15.60.60 at 4% for another 6 months, which gives us interest of $31.21. Again, slightly more than it was the last 6 months. This gives us a new maturity value of $1,591.81. During our last 6 months, we'll use that $1,591.81 as our principal. We'll use that at 4% interest for the remaining 6 months, which gives us $31.84. Again, slightly more than the last bit of interest. This gives us a maturity value of $1,625.65. So when we compounded the interest, we got a maturity value of $1,625.65. If we had just done simple interest the entire time, so if we had just done the maturity value at simple interest, we would have had the principal, which was the original $1,500 times 1 plus RT, or 0.04 times 2 years, $1,620. That one skipped the line there. So we'd have simple interest would have been $1,620. Do you see the difference? The difference between compounded interest and simple interest. The compounded interest was slightly more, $5.65 more. Not a lot, but just a little bit. Compounded interest will always be more than simple interest. When you look at a chart comparing the growth, you see here in the green what happens with compounded interest. You see in the red a simple interest formula. Notice how the red is a very steady increase. It stays the same versus the green, which starts the same but then sort of shoots up like that. That's known as a compounded growth. The simple interest just stays steady. And of course, the principal, if we hadn't invested it at all, would have just stayed the same, and that's the blue line. In the very beginning, the difference between simple interest and compounded interest is basically pocket change. There's really not a whole lot of difference in those first 4-ish years between those two amounts. It's not until we give time is what makes all the difference between compounded and simple interest. So the next section is section 11.2, and in 11.2 we are going to be using the tables, table 11.1 if you are in your textbook, or the future value table if you are looking at the printout that I offered. All right, so this is a copy of the future value table. You will see that across the top we have percentages, and down the side we have 25 periods. Then halfway through we start with more percentages, 9, 10, 11, and 12, and another 25 periods. We're going to use the future value table in order to help us calculate compounded amounts. In order to use the future value table, we need to be able to identify 3 different things. The first is the interest rate per period. This is your stated or yearly rate divided by the number of compounding periods in a single year. This is known as a lowercase I, and the formula for it, or the description of how to find it, is to take the nominal or yearly rate and divide it by the number of compounding periods in a single year. That's how you find I, or the interest rate per period. The second thing you have to be able to find is the total number of compounding periods. Now, in order to find the total number of compounding periods, you need to know how many compounding periods are in 1 year and multiply that by the number of years that you have to compound. So the number of compounding periods in 1 year times the number of years in the investment or loan. Lastly, you have to be able to find the compounded amount. This is the principal. This is the principal, multiplied by the table factor. So the compounded amount also sometimes called the future value or the goal amount, should be the principal times the future value table factor. All right, let's see how this goes. Sometimes these take a while as I'm tabbing through them. So we'll just talk to you for a minute. There we go. Hi, interrupting Amy here. I just wanted to make clear a couple of pieces of information. Number one, you will need to know both the I and the N from the previous few minutes of video. The table factor, we're not using that this term, so you don't need to know about it. You can ignore that table factor in this particular section and in the sections to come. As we move forward, you will need to have a scientific calculator available to you. If you don't have your own, that's okay. Your phone has one, and you can always use the website mathway.com in order to help you. It allows you to see what you've inputted and press enter to arrive at the answer. And now we're going to take the I and the N, and we're going to use it in the compound interest formula. Coming right up. All right. The last section from 11.1 is the compounded interest formula. This is a somewhat complicated formula. You will need a calculator with an exponent key in order to figure these guys out. Don't think you can necessarily just use your phone calculator or just use your computer calculator unless you know the trick about switching it in order to get your exponents. So the formula for compound interest is as follows. A is equal to P times 1 plus I to the nth power. This is A, as in the total or compounded amount, is equal to P, your principal. That's the amount of the investment or of the loan, times the quantity 1 plus I. This is your interest rate per period. We've been finding it for the last 35 minutes. It is still the same. N is your total number of compounds. It is what we've been finding for the last 35 minutes. You still have to find your I and your N as we did previously. We're now just going to put it into this formula. When do we use the compounded interest formula? 2 occasions, really. As we had said, in real life, your interest rates are not whole numbers. I mean, my car loan was like, I want to say my car loan was 2.3%. My very first home loan was 5.4%. So they don't all come in a table, or the table needs to be like a tome. Tome might not be a word you're used to. A tome is a very large book, right? It could be a very large book. And before we had computers, they were all in very large books. Now you just put it into an Excel spreadsheet and the banker does it for you. But sorry, I digress. All right, let's try a problem. I have my scientific calculator here. This is the one that I normally use. This is the one that I recommend for class. It's just a TI-34. Any calculator with a fraction key and an exponent key will work. All right, so let's take a look here. So here we have calculate the future value of $22,560 if the interest rate is 7.2% compounded monthly for 8 years. So even to use the formula, I still need to find the interest rate per period. The main difference here is that you will do the interest rate, the percent, as a decimal. So when I do I, purposefully to put it into the formula, I'm going to use the annual interest rate as a decimal. That's the main difference. And I'm still going to divide it by the number of compounds in a year. So 7.2% as a decimal would be 2 places to the left, or 0.072. Since it's compounded monthly, I'm going to divide that by 12, and that's going to give me 0.006. So my I value, or interest rate per period, is 0.006. My total number of compounds would be 12 times a year for 8 years, or 96. 96 never would have been on our table. So with those two values, and knowing the principal is 22,560, I'm going to substitute them into the compound interest formula. I know A is equal to P times 1 plus my I to the nth power. So this would be 22,560 times 1 plus 0.006 to the 96th power. So 1 plus 0.006, do what's in parentheses first, to the 96th power. This is, well, it's a basic calculation. You have to do the power first. 1.006 to the 96th power. On most calculators, on the TI-30 calculator, what you want is in the first column, and it's about halfway down. It's called a chevron key. I'll hold it up there. See, whoops, go the other direction, Amy. Right here. Looks like a caret or a chevron, right? So we're going to take 1.006 to the 96th power, and we're going to get 22,560 times 1.775849466. You don't want to round this. You do not want to round. The bank will not round. It takes money out of their pocket. Banks will not round. So we are not going to round. We are going to keep all the decimals. Now, if you know how to use your calculator correctly, you know you won't have to clear and retype that. You can just get 1.006 to the 96th power, and you can just multiply that times 22,560 to get $40,063.16. We're rounding to dollars and cents, all right? If, as you do this, you're having problems figuring out your calculator, then you may want to go ahead and schedule an appointment with myself or Tim, where we will help you work through how to get this done. I will also put up a video, but the problem is that not everybody uses the same calculator. So I may not hit all of your issues. You may have to log on with me at some point this week to get it figured out. Here is a second example. Find the amount of an $89,000 loan compounded quarterly at 5.4% over 30 years. This is approximately my first mortgage. So my house cost me about $89,000. That was back in 2002. Some of you were probably just born. And it's compounded quarterly at 5.4% over 30 years. So we're going to do the same steps. I still need to find the interest rate per period. And in order to do that, I'm going to find the annual interest rate as a decimal, and I'm going to divide that by the number of compounds in a year, or 0.054 divided by 4, which is 0.0135. I need to find the total number of compounds. Well, if we're compounding 4 times a year for 30 years, that's going to be 120 compounding periods. I'm going to substitute these values into the formula along with the principal of $89,000. So I'm going to have $89,000 times 1 plus 0.0135 to the 120th power, or 89,000 times 1.0135 to the 120th power. Doing that first exponent, so 1.0135 to the 120th power, I have to do that part first. That gives me 89,000 times 4.998622773. I need to keep the whole number, or $444,877.43. Again, if you're not getting that number, please schedule some time with me. Reach out via email. Ask me to send you a video specific to your calculator. There we go. I just couldn't get those words up. I don't know why. All right, here I have 3 other examples. Determine the future value of $5,000 at 8% interest compounded semi-annually for 18 years. Our I value would be the 8%, 0.08, divided by 2, because we're compounding semi-annually, or 0.04, Total number of compounds would be 2 per year for 18 years, or 36. The formula then would be 5,000 times 1 plus 0.04 to the 36 power. Working this out on the calculator, we get $20,519.66. Second example, the value of $250,000 at 2.4% interest compounded monthly for 6 years. 2.4% interest as a decimal would be 0.024. We're going to divide that by a monthly compound of 12 compounds in 1 year, to get 0.002. Total number of compounds would be the 12 per year for 6 years, or 72. Then substituting these values into the formula along with a principal of $250,000, I get 250 times 1 plus 0.002 to the 72nd power, or $288,679.51. Lastly, we have the future value of $9,000 at 13% interest compounded daily for 3 years. Okay, we're going to get a huge number here because 13%, no, that should be 1.3. That should be 1.3% interest. Hold on, let me fix that. We're going to put a decimal point there, and then I'm going to fix it later. Pen, decimal point, 1.3% interest. Why? Because nobody gets 13%. Nobody. All right, done. Okay, so then if we fix that up, I don't want a laser pointer either. What's that doing? Okay, then what we're going to have is 0.013, because it's 1.3%, times, or divided by 365, because we're compounding daily. That means every day I earn a little interest and they dump it into my account so I can earn a little interest on that interest. Look at the number I get, 0.0000356161. Okay, my N value here, total number of compounds, would be 365 compounds a year for 3 years, or $1,095. Substituting those values into the formula, we'd have 9,000 times 1 plus, and I didn't want to write that whole number in. No, I did not. So I just used 0.013 divided by 365. You can do that. In most calculators, it will work. And if you've taken, an Algebra 2 course and maybe a geometry or pre-calc, you're probably pretty savvy about how to get that done on your calculator. We're going to take that to the 1,095th power. Woo! Ooh, go back. I slapped my keyboard. There we go. And we're going to get $9,357.93. Yankees. Okay. Last slide here with practice on it. If you want to, you can skip over this part. I'm just going to click through. These all use the formula A is equal to P times 1 plus I to the nth power. And I've gone ahead and worked through this. You can check your understanding by doing these problems yourself and then pausing and clicking through this with me. I would say probably the hardest one is the $15,000 for 25 years at 5% compounded daily. That's like the example that we just went through, where it's probably to your benefit to keep the 0.05 divided by 365 rather than typing out all of the numbers. So that would be the only one. All right. That is the last bit of Chapter 11, Section 1. So at this point, do you feel like you could work through a manual calculation of compounded interest to help you with understanding? Do you feel like it helped you? I'm not going to make you do another manual calculation, but do you feel like it helped you? Do you feel like you could use the future value table, including finding the interest per period and the total number of compounding periods? Could you calculate the compounded amount and separate interest from principal? Could you tell me how much was interest and how much was principal? Are you familiar enough to be able to calculate a table factor beyond the table? You will have resources, so while I've talked you through that type of problem, do you feel like you could do so yourself? Could you calculate an APY or an annual percentage yield? Could you use a compound interest formula, including identifying and finding each part of the formula and using a calculator to find the actual compounded interest? And of course, separating that interest from the principal. This is a lot of things in this presentation. Do you feel comfortable doing all of these things? There is extra practice. This is Chapter 11, Section 1. It is at the end of the section in your e-text. There are, I believe, 39 review exercises. You could do as many or as few of those as you like. And if you have a physical copy of the textbook, I believe this is pages 350 to 353. Either if it is not, it will still be at the end of Chapter 11, Section 1. There is, of course, a graded assignment that goes along with this presentation. It is located on WebAssign and is oh so creatively titled Chapter 11, Section 1. As always, if you have any concerns or need any assistance, please feel free to contact your instructor, the embedded math support personnel, the Math Center, and any tutors you may have available to you. Thank you so much. We are all here to help.